All right, we're going to begin Chapter 1, Section 8a, which is solving quadratic inequalities. All right, so solving quadratic inequalities is somewhat similar to solving absolute value inequalities. You're going to have a couple different values to plot on a number line, and then you're going to test to see where there are valid solutions, right? But essentially, you would just get your inequality greater than or less than 0, right? So just like with equations, right, majority of times we want to get 0 on one side of the equation, everything else on the other side. And then you're going to solve it as though it already had an equal 0. And then you're going to set up test points on your graph to see where we have valid solutions. All right, so let's actually try these, right? Something like x squared minus 2x minus 3 is less than 0. I'm just going to pretend that this was equal to 0. So I'm going to say that this is x squared minus 2x minus 3 equals 0, right? We're going to write our answer in interval notation, all right? So let's just pretend this equals 0, and let's just say we're going to factor this as x minus 3, x plus 1, and then we get two answers, x equals 3 and x equals 1, right? So these help us, right? But these aren't really our final answers, all right? What really would happen here is I would have to draw a number line and kind of test where we're going to have valid solutions, right? So -1 would be right here, 3 would be right here, all right? And then what these points do is they kind of split up our number line into 3 different sections, right? You see that we have a section here, here, and here, right? We have 3 different sections. What we want to do is we want to test and see which ones work, right? And you want to make the work as easy as possible for yourself, and I'm just going to pick an easy number to work with, which is, 0, right? So I'm going to pick a point right here at 0. Now 0, you see, is going to be in between these two numbers, -1 and 3, so I'm testing this entire region, all right? So I'm going to plug in 0 into our original inequality, and we're going to see if this is a true statement, all right? So then 0 squared goes away, -2 times 0 goes away. I get -3 is less than 0. All right, now is this a true statement, right? It is, right? And if it's a true statement, that means this entire middle section works and these outer two do not. So I'm going to shade in between. And because this was a strict inequality, I'm going to have open circles. All right. You can also think of it like this was a less than. And in our previous lesson, I had showed you guys that you can do less than, right? And great or than, right? To see if it's an and or an or. And ands are going to shade in between. All right. But I like to do the test points, right? Maybe if you know that an and is going to shade in between, you probably could have skipped that step. But I like to do it just because you're going to see our very last example of this lesson is going to be something where there's going to be multiple sections that we'll maybe have to check. All right. Now writing this answer in interval notation is going to go from left to right, right? From -1 to 3. And I'm going to have parentheses around these because I have open circles. All right. Now what this is saying, just like we learned in the previous lesson, is that any value from -1 to 3 is a valid answer, all right, but not including those two answers, all right? So let's try the exact same thing with the next one. All right, you're going to see that as we do more of these, it's not so bad, right? Again, pretend that this was equal to 0, and then I can solve as normal, right? So this is going to get me an x minus 3. I'm sorry, an x minus 3, sorry. And then an x plus 2 equals 0. All right, and then I get two answers, x equals 3 and x equals -2. All right, and then I can use these numbers to plot on a number line and test points, right? So I'm going to have a -2 right here, a 3 right here, and then keep in mind this is going to split up our number line into 3 different parts. All right, the easiest thing to check is 0, right? So if I plug in 0, 0 is between -2 and 3, so I'm testing this entire region. So I'm going to do 0 squared minus 0 minus 6 is less than 0. I'm going to see if this is true, right? 0 and 0 go away, so this is going to get me -6 is less than 0, and that is true. That means this entire section works, all right? So this middle section works, and these outer two do not, right? The sections alternate, and you're going to see that in the next example. Because this is a strict inequality, I'm going to have open circles. And around open circles, I'm going to have parentheses. So this is going to be -2 to 3. And then that's our answer in interval notation. All right, let's try the exact same thing with the next one. All right, so again, you can pretend that this was an equal sign and then factor it like normal. So this is going to get us an x minus 5 and an x plus 4 equals 0. So I'm going to get x equals 5, x equals -4, and then I can plot these on a number line. All right, so -4 would be right here, 5 would be right here, and again, this splits up our number line into 3 different parts. I'm going to test the middle region again by picking 0, right? 0 is going to fall between these two numbers. All right, so when I plug in 0 into the original inequality, I get a 0 squared minus 0 minus 20 is greater than or equal to 0. So I get -20 is greater than or equal to 0. This is false, right? 0 is not less than -20. So this middle section does not work. That would mean that outer sections do work, right? And because this has equality, I'm going to draw closed circles around these, and I'm going to shade in the regions that work, all right? And then I can go from -infinity to -4 in that first interval, right, with a bracket, right? There is a gap, and remember from the previous lesson, the gaps we're going to represent with the letter U, or not the letter U, but this U symbol, right, which represents the union. And then our next interval is going to start at 5, and then it's going to go all the way up to infinity. And then that is our answer in interval notation. All right. So let's try the same thing with this one. All right, this is another one that we can factor. Again, just pretend that this was equal to 0. And then I'm going to do, it looks like we can do 4 times -6. So I need factors of -24 that add up to -5. And that's going to be a -8 and a +3. So then factor this however you're comfortable factoring. So I'm going to do x minus 8 and x plus 3 equals 0. And then I can divide by the number in front, which is 4. So divide by 4, I get x minus 2 and 4x plus 3 equals 0. So I get x equals 2 and I get x equals -3/4. All right, and so I can plot these again on a number line. So the -3/4 is going to be somewhere right here, and then I get 2 right here, and so I can split up my graph into 3 parts. And then again, the easiest number to test is 0, right? Anytime you can check 0, I would check 0, right? Because that makes your calculation super easy. So this gets you 4 times 0 squared minus 5 times 0 minus 6 is greater than 0, right? 0 is nice because things cancel out, right? So then I end up with -6 is greater than 0, right? Which is false, right? So that means this entire middle section does not work, and these outer sections do work. And because this is a strict inequality, I'm going to have open circles, and I'm going to shade on the outsides. All right, and then if I have 2 different intervals, I'm going to go from -infinity to that first one, so -3/4 with the parentheses, union, and then I would go from 2 to infinity with parentheses, right? And this is my answer in interval notation. All right. And that's the essence of this lesson, right? The only time where they get harder is when they don't factor, which we'll do an example like that. And maybe when there's higher exponents, maybe not particularly a quadratic, which we'll also get to later. We'll actually get to both of those in the same slide, right? Our very last slide. All right, so we can solve this like normal, right? Looks like this one. Looks a little bit different just because it's not in standard form, but we want to get it in standard form. So I can distribute x and make this into an x squared plus x is less than 12. And then I can subtract 12 on both sides. And then I get x squared plus x minus 12. I'm just going to set this equal to 0, right? Just because we don't really care about the symbol. Only at the end when we're testing values do we care about that. But I can just set it equal to 0, and then I can say that this is x plus 4 and x minus 3 equals 0, right? So I get x equals -4, and I get x equals 3. And then I would use these values to plot on a number line. All right, so -4 would go right here, 3 would go right here. Because this is a strict inequality, I would have open circles. Now I want to see where to test. All right, 0 again is a good one because it goes right in between the two. And then I would plug it into the original. I have 0 times 0 plus 1 is less than 12. And then 0 times anything is 0. So I have 0 is less than 12, which is true. All right, so that means I would shade in this middle section right here. Interval notation from left to right is going to be from -4 to 3 with parentheses, and then this is my answer in interval notation. All right. Same thing with this next one. So you can move the 16 and then factor it, right? We get x squared minus 16. I'm going to say that this is equal to 0. And factoring this, we get an x plus 4 and an x minus 4. Right? Another thing that you could have done from the beginning, you could have just changed it to equal and then square root both sides. And then don't forget the plus minus, right? That's another valid way to do it, right? Maybe some of you saw that instead. All right, and then we would get two answers, -4 and 4. All right, and then I would put this on a number line, so -4 would go right here. 4 would go right here. All right, and then I want to test, right? Let me try 0. All right, so I'm going to do 0 squared is greater than or equal to 16, right? Which is not true, right? 0 is not greater than or equal to 16, right? So this entire middle section does not work. That would mean these outer sections do, all right? Because it's with equality, I'm going to put a closed circle and then shade on the outsides. So my answer in interval notation from left to right would be from -∞ to -4 with a bracket, all right, a little union. Another bracket from 4 to infinity. And then that's your answer in interval notation. All right, so hopefully you see these aren't too bad, right? It's just essentially solving quadratics and then testing a value to pick. All right, this last slide is where things get a little tricky, but it's still the same idea, right? I'm going to get 1 to the other side, and then I get x squared plus 4x plus 1. I'm going to say that this equals 0, right? And notice that this can't factor. We don't have factors of 1 that add to 4, right? So what we can do instead, we have two options. We can do quadratic formula, or we can do completing the square, right? And I will say, for this one, I like completing the square, right? I will always like completing the square when a equals 1 and b is even, right? Because that's not going to give us like fractions that we have to square or anything, right? And even if you did the quadratic formula, you should get the exact same answer. You'll just have to simplify a little more, and you might find yourself doing a little bit more work than necessary, all right? So I'm going to complete the square for this one. Hopefully you remember that process. I can move the 1 to the other side. I get an x squared plus 4x plus a little blank equals -1 plus a little blank. And then in that blank is going to go b over 2 squared. So I'm going to do 4 over 2 squared. So 4 over 2 is 2, and 2 squared is 4. And then this side is going to become a perfect square trinomial. So it's going to be x plus 2 squared equals -1 plus 4 is 3. All right. And then so from here, I can square root both sides. And then I get x plus 2 equals plus minus the square root of 3. And then I can subtract 2 to both sides, and I get x equals -2 plus minus the square root of 3. All right, now the tricky thing here is trying to figure out where they go on a number line. And more tricky than that is trying to figure out which value to test. All right, well, keep in mind, we do get two answers here. One of them is -2 plus the square root of 3, and the other one is -2 minus the square root of 3. All right. Now, plotting these on a number line, right, it's a blank number line, is going to be super easy, right? Obviously, the one with the minus is going to go first. That's going to be smaller. And then obviously the one with the plus is going to be bigger, right? If I add instead of subtracting, I'm going to get a bigger number. Right? Now, the difficult thing here is trying to figure out where 0 is on this interval. All right? Now, 0 should be somewhere over here. It's going to be right there. Now you're probably thinking, how did you get that? Right? Well, let's think about it. right? I don't know what the square root of 3 is, but we don't need to know the exact value. We just need to have some number sense, right? I'm going to do this up here, right? So if I have the square root of 3, I know for sure that that's going to be less than the square root of 4, right? Why did I pick the square root of 4? Well, because I know that the square root of 4 is 2. So I know for sure that the square root of 3 is less than 2. I also know for sure that the square root of 3 is bigger than the square root of 1. Again, why did I pick the square root of 1? Because the square root of 1 is just 1. So I know that the square root of 3 for sure is somewhere between 1 and 2. So I'm just going to say that the square root of 3, let's just say, for example, that that's about 1.5. All right, I know for sure that it isn't, right? But let's just say it's about 1.5. All right, if I were to do negative 2 minus 1.5, that would get us a minus 3.5. And if I did minus 2 plus 1.5, that would get us a negative 0.5. So no matter what this is, whether it's 1.5, 1.7, 1.999, right? It doesn't matter what it is. As long as it's less than 2, it's going to be a negative number, all right? And so 0 would be on this side. So 0 for sure has to be bigger than whatever this value is, all right? So we can test 0. If that didn't make sense to you, there's another value that you can test that's right in between these two, right? And that's actually negative 2, right? If I have negative 2 plus 1.5, I know that that's going to be 1.5 units in that direction. If I do minus 1.5, I know that that's minus 1.5 in that direction. And I know for sure that negative 2 has to be right in the middle of those two. All right, so you could test the middle interval by doing negative 2, or you can test this interval by doing 0. All right, let's just stick to what we've been doing and let's try 0. I'm going to plug 0 into the original inequality, and this is going to get me a 0 squared plus 4 times 0 is greater than negative 1. And then this is going to get me zeros cancel out. 0 is greater than negative 1, which is a true statement, right? So that means I am going to shade in this region, right? So that works. The middle doesn't, and that works. Because this is a strict inequality, I'm going to have open circles. And so my answer in interval notation is going to be negative infinity to negative 2 minus the square root of 3 with a parentheses, union negative 2 plus the square root of 3, comma, infinity, right, with parentheses. And then that's our answer in interval notation. All right, if you had tested negative 2, then we would have got negative 2 squared plus 4 times negative 2 is greater than negative 1. Negative 2 squared is 4. 4 times negative 2 is 8, minus 8. And then I get negative 4 is greater than negative 1, which is not true, right? Either way, we get the same thing, right? The middle doesn't work, but the outer ones do, all right? Okay, so now let's try the exact same thing with the last one. Well, not the exact same thing, sorry. I'll try the same process with the last one of getting it equal to 0. All right, so let's add 48. And then so I end up with 2x to the third minus 3x squared minus 32x plus 48. And I'm going to say that this equals 0. All right, this one's different because it's not even a quadratic, right? It's to the third power. All right, but we can still factor it like normal. I'm going to group, and then I'm going to take out an x squared, and I'm left with the 2x minus 3. I can take out a negative 16, and I'm left with the 2x minus 3. All right, and then so I'm left with an x squared minus 16 times 2x minus 3 equals 0. And then I can factor a little more, or you can just solve that one by square rooting, doesn't really matter. Okay, so we get x plus 4, x minus 4, 2x minus 3 equals 0. And then so solving this, I get x equals negative 4, x equals 4, and x equals 3 halves. All right, and then so I'm just going to plot these on a number line. All right, negative 4 is our smallest value. 3 halves is our next smallest value, and then 4 is our biggest one. All right, and again, anytime you get a chance, I would test 0, and 0 is between negative 4 and 3 halves, right? The difference with this one versus the other ones is now that when I split this up, I actually have 4 different intervals. But again, the same pattern as always, right? It's going to alternate. So I'm going to test 0, and I'm going to see if it works. So I get a 2 times 0 to the third minus 3 times 0 squared minus 32 times 0 is greater than negative 48. And then 0 is what we get on this side. I get 0 is greater than negative 48, and that is a true statement. All right, so that means this middle section works. The ones on the outside of it do not, and this outer section does work. So I'm going to shade where it works. And because this is a strict inequality, I'm going to have open circles all around. And then from left to right, it's going to be negative 4, comma 3 halves with parentheses, union 4, comma infinity, also with parentheses. And this is our answer in interval notation, going from left to right. All right. And so that's essentially all you need to know for this lesson. All right, that's about as complex as they get. You can't really expect anything much harder than that, right? So hopefully this section isn't too bad.